Things like pinch to zoom, swiping through photos, or rotating a map with two fingers, multi-touch is just so baked into our lives now, it's hard to imagine a time without it. But every piece of tech has an origin story. Today, we're going to rewind the clock to 2006, to a really foundational research paper that was exploring the power of multi-touch long before it was in all of our pockets. So, let's dive into the big ideas from that groundbreaking work.
Seriously, just take a second and try to picture that. The frustration, the clumsiness, how incredibly inefficient that would be. Well, this single, powerful analogy is exactly how researchers describe the state of human-computer interaction for like decades. For all the amazing power of our hands, our ability to coordinate, to manipulate, to feel the world, we were basically reduced to just poking at the digital universe with the single point of a mouse cursor. We were, as the researchers put it, stripped of our dexterity. So yeah, let's start with this core issue, the one-finger problem. See, this research didn't just accept the mouse and cursor as the end of the story. It asked a pretty profound question. Why are we forcing our wonderfully complex hands to act like a clumsy single finger? And that, of course, leads us to the solution. The whole goal of this work was to break free from that single point of control and start designing interfaces that actually tap into the natural, fluid dexterity our hands have had all along.
And this comparison just lays it all out so perfectly, doesn't it? On one side, you have how we interact with the real world. It's fluid, coordinated, continuous. And on the other, the computer world. Clumsy, one action after another, just a series of disconnected clicks. The mission was to make our digital life look a lot more like our physical one. Now this is crucial. Multi-touch, in this context, wasn't just about using two fingers instead of one. No, it was a fundamental shift in philosophy. The whole idea was to move away from these discrete, sequential commands and move toward continuous, coordinated movements. It's about transforming how we interact into something more expressive, almost like painting. Okay, so how do you prove a concept like this works? Well, let's look at their first big application. They decided to take on a notoriously complex task, computer animation, and they asked, hey, can we make a digital drawing feel like a physical, flexible prop that you can actually hold in your hands? And here it is, right here in action. They called this performance animation. So instead of painstakingly setting keyframes one by one, the user just plays with the drawing. You touch it, you bend it, you wiggle it with your fingers as if it were a piece of rubber. The digital object literally becomes a prop, and the user becomes a puppeteer.
And the reason this is so effective is because it captures all the subtle, organic imperfections of human movement. Traditional animation tools, especially if you're a novice, can create really stilted, almost robotic motion. But this technique, it creates an animation that just feels more natural and alive, precisely because it isn't perfect.
This quote is the ultimate proof of how well it was designed. There was no complicated manual, no training needed. The interaction was so natural, so perfectly aligned with how we experience the real world, that the best way to explain it was to just let people try it. Try touching it. That's all it took. So direct manipulation, that's a huge win. But the research team didn't just stop there. I mean, what about the millions of us using laptops with touchpads? Well, they also explored how these same multi-finger principles could completely reinvent the traditional indirect cursor. Think about it for a second. The standard mouse or touchpad, it just tracks an X and a Y position. That's it. But our hands can provide so much more data. The distance between our fingers, their orientation, how many fingers we're using. The goal here was to create a brand new kind of cursor that could harness all of that rich information. So their first idea was this hand cursor, which basically maps the touch points of your fingers directly onto the screen. This simple concept suddenly lets you do something that's totally impossible with a normal mouse, translate and rotate an object at the same time. This is basically the great-grandparent of that two-finger rotate gesture we all use on maps today. The next step in this evolution was to kind of abstract those finger inputs into a single, unified cursor. And now, suddenly, a user could control an object's position, its rotation, and its scale, all in one single fluid gesture. I mean, that foundational idea, combining multiple actions into one, that's exactly what makes pinch to zoom feel so incredibly natural. All right, next up, we've got the adjustable area cursor. And this is where things get really clever. Spreading your fingers wide creates a big, forgiving selection area, perfect for grabbing an object that's all by itself. But pinching them together makes the cursor tiny and precise, so you can pick something out of a crowded space. The tool just adapts to what you need to do, instantly and intuitively.
So at the end of the day, these new cursors were just a massive leap forward. They brought together separate actions into single, fluid ones. They mimicked how we actually handle things in the real world, and they let you seamlessly switch between grabbing something big and selecting something small, all without ever changing tools.
So it all seems so simple and powerful in hindsight, right? The animation tool is a total breeze, the cursors are brilliant, so you might be asking yourself, okay, so what was left to do? Was the problem solved? Well, as it turns out, creating this technology was really just the beginning.
Because building these amazing tools actually opened up a whole new field of questions. This wasn't just about engineering anymore, it was about the science of touch. For the very first time, researchers had a way to ask these really fundamental questions about how our hands and our brains coordinate in a digital space.
And the researchers, they immediately saw these huge unknowns. What is this stuff actually good for? What are our physical and mental limits when we're trying to control multiple things at once? And how is using 2 fingers on one hand different from using 1 finger on each of 2 hands? Answering these questions would be absolutely essential for the future of interface design.
And they were already uncovering some fascinating insights. For instance, their early work suggested that if you need to control 2 things separately, using 2 hands might actually be better. But if you need to perform one single integrated action, like rotating and moving something together, 2 fingers on one hand might be the superior way to do it. It's a super subtle but really crucial distinction.
You know, looking back, this 2006 paper wasn't just about inventing new features. It was about imagining an entirely new relationship with our digital devices, one based on dexterity and intuition. It really makes you wonder, with all the incredible tech we have today, from VR to brain-computer interfaces, what fundamental limitations are we still just blindly accepting? What future, more natural interactions are we just failing to even imagine right now?